Hey everyone. Today, I want to take you on a quick journey into the world of LSTM networks' long short-term memory. If you've ever wondered how machines remember things over time, like the context in a sentence or the notes in a melody, LSTMs are the secret sauce behind that magic. Let's start with the basics. LSTM is a type of recurrent neural network, or RNN. Traditional RNNs are great at handling sequences, but they hit a wall when it comes to remembering things from far back in the data. Why? Because of something called the vanishing gradient problem. Imagine trying to recall what you had for breakfast 3 months ago. Yeah, it's kind of like that for RNNs. So, what makes LSTMs special? The answer is in the name memory. LSTM networks have this clever component called a cell state. Picture it as a conveyor belt running through the entire network. Information can flow along this conveyor belt with only minor tweaks, so important details don't just fade away over time. But how does an LSTM decide what to keep, what to throw away, and what new information to add? That's where the magic of gates comes in. There are 3 main gates in an LSTM: the forget gate, the input gate, and the output gate. Each gate is essentially a neural network layer that learns what information is important. Let's break them down. First up, the forget gate. This gate asks, what information from the past should I forget? For example, if you're processing a sentence and a topic suddenly changes, the forget gate helps the network drop the irrelevant details. Next, the input gate. This one decides what new information should be added to the cell state. It's like opening a door and letting in only what's useful for understanding the next step in a sequence. And finally, the output gate. This gate determines what part of the current cell state should make it to the output. In other words, what should the network pay attention to right now? All these gates work together, allowing the LSTM to keep essential information for a long time and ignore what's unnecessary. That's why LSTMs have been such a game changer in fields like speech recognition, language modeling, and even music composition. If you've ever used voice assistants, real-time translation, or predictive text, you've seen LSTMs in action, quietly making things smarter and more intuitive. So, to sum up, LSTMs are like the memory keepers of AI. They use a combination of a memory cell and smart gates to decide what to remember, what to forget, and what to output. That's how they master long-term dependencies, making them super useful for all kinds of sequential data. Thanks for joining me on this quick breakdown of LSTM networks. If you're curious about how these ideas actually play out in real-world AI, stick around, there's always more to explore. Until next time.